Hi guys! In this video, I want to show the basic techniques of working in a Blender using an Octane render. I'll show you how I set up the file to work, some simple modeling techniques, creating procedural materials using a composite texture node, and rendering a simple scene. Let's start with a clean slate. First of all, I will choose an Octane render engine. Let's run the rendering in the viewport. Before that, you need to connect the Octane server and wait for the connection. I don't have any of the rendering core options selected right now. This can be seen in the window with the selection and settings of the render engine. In the sidebar in Render Setup, I will create a new rendering node tree. By default, a direct lighting core is created. In the drop-down list, change it to ray tracing. The path tracing core is considered the best option to achieve a balance of speed and quality, and the results are more realistic. Moreover, the scene has become black, and this is due to the fact that there are no light sources and no surroundings now. Open the Materials Editor, switch it to the settings of the surrounding world, and create environments. Connect the RGB image node to the environment texture node and add an HD Paradise texture. Now this texture will work as an ambient highlight. In order to disable its visibility in the viewport, set the alpha channel value in the rendering settings. Switch the Material Editor to Object Mode and create a material for Suzanne. Let's set some preliminary rendering settings. To get the rendering result, a camera is needed. Let's create a camera and place it to the right of Suzanne. Let's create another camera and place it on the left. Each camera, no matter how many of them there are in the scene, has its own independent settings. To begin with, let's change the parameter passport. This option darkens the area outside of the camera's field of view. This will speed up the rendering of areas in the camera's field of view. Then, in the settings of each of the cameras, for example, we will change the exposure and saturation values. We will do the same for the second camera, but with different values. Switching between cameras, you can see that the appearance changes. Let's check how it will look when rendering. Open the Image Editor, select the rendering result from the list, and execute the render from the first camera. You can see that the image is completely consistent with what we observe from the camera in the viewing window. Now let's switch to the second camera and also perform visualization. The result is the same. The final image corresponds to what we observe from the camera in the viewing window. Now let's open the sidebar and activate the Use for All Cameras option. Now the viewport displays what corresponds to the settings in this sidebar. And now these settings affect all cameras in the scene. Let's do the rendering. As we see, the result is exactly the same as what is displayed in the viewport. If you now activate the camera image rendering mode function, then when rendering, the previous settings will be replaced with the settings of the camera from which the render is performed. This can be misleading, so it should be remembered and taken into account when setting parameters for each camera, or for all cameras in the scene. In this example, I will choose the option of the same parameters for all cameras in the scene, to avoid confusion. All of this works in the same way with post-processing. I will reset all values. In the settings for all cameras, I activate the ASIS parameter, which will make the image more photorealistic and cinematic, due to better processing of light and shadows. It is also important to change the filmic parameter to RAW in the color management settings, in order to get an image from the blender without any transformation of the color space. In the environment settings, I will increase the ambient light intensity, and also increase the number of simples in the rendering settings. The basic construction has been completed, now you can start working. In the scene settings, I will change the units of measurement to centimeters. It is important that the objects correspond to their actual dimensions. I will create a cylinder and set the value by height and radius. I will add a bevel using a modifier. I will duplicate the object and resize it in edit mode. I will create an internal recess using the insert command. I will add a surface subdivision modifier to both objects. Now we will adjust the materials. In the materials editor, I will create a material for the upper part. As a basis, I will use the procedural node of wood. To scale the pattern, I will add a transformation node. When you change the scale, it does not get the result that you would like. Connecting the projection node also does not give the desired result. In this case, I will use a triplanar projection node and a triplanar map node. These nodes provide the ability to transform textures locally for each axis of the projection. By changing the scale in the node of the 3D transformation, we get the desired result. Next, we configure the wood node for the relief. I will connect the same texture to the bumper, adjust its intensity and the overall roughness of the material. On the top part, I want to place a logo. To do this, you need to edit the same app. In the Java editor, I will reduce the size of the islands on which there will be no logo texture and maximize the fragment where the logo texture will be placed. To create a logo, I will use an online editor that resembles Photoshop in some way. We create a document with a size of 2048 pixels and add a vector shape from the provided set of blanks. I place it in the center of the document and save the image, create an image node, and connect the texture with the logo. In the C editor, you can edit the size and position of the logo. Now you need to mix the wood texture and the logo. To do this, I will use the texture mixing node. I will connect the first and second slots to the tree texture and add a color correction node. I'll set it up so that the logo color is darker than the main drawing. As a mask, I will connect a black and white image of the logo. In addition to the difference in color, I want the logo to have a relief in the form of embossing. To do this, I will create an offset node and connect the texture to the offset slot. Let's adjust the parameters for a good result. I will set the average level to 1, reduce the offset height, and add a Gaussian filter to smooth out the corners. Now you can see the artifacts on the top. They are related to the fact that the upper polygon is one large polygon that the surface subdivision modifier does not work well with. To fix this, you need to replace it with a uniform grid. In edit mode, I will squeeze the upper polygon to the center and delete it. Then, having selected all the edges, I will close the hole with a grid. I will scan the upper part again. Now it can be seen that part of the problem has been solved. However, some artifacts are still showing up. This is due to the fact that the object size is only a few centimeters, and I noticed that with small-sized objects, the offset texture behaves strangely. But if you reduce the value of the detail level, the problem disappears. Well, the top part is ready. Now let's take care of the lower part, which consists of the cork material. I will customize this material using composite texture nodes. I will connect a composite texture node to the bump node and add the first layer. This layer will contain a procedural texture. Sorry guys, I can't pronounce its name correctly. With the help of the transformation node, I adjust the scale, and to control the contrast, I use made gradient maps. Composite texture layers are convenient because you can change the opacity parameter and thereby influence the intensity. Then, I add a second layer. It will also use a procedural texture. This is noise with a type of noise called chips. I also use the gradient map to adjust the contrast and scale in the transformation node. In the settings of the composite texture layer, you can mix layers by changing the opacity parameter as well as through overlay modes. This is probably the coolest thing about composite textures. I add a third layer and a procedural noise node. With this node, things are different. To display it correctly, you need to add a node of the BioVi projection. The reason for the stretched areas is again related to the surface subdivision modifier. The problem is solved by adding several sections. After playing around with the parameters, I finally got an appearance similar to cork material. But this is still only a relief. Now you need to do the color. Here, I will use the composite texture node again. For the first layer, I will use the already configured procedural drawing from the top of the model. By changing the parameters, I get the pattern I need. Setting up procedural textures takes time, but at the same time, gives you freedom in editing. For the second layer, I'm using procedural texture nodes again. This layer is needed to obtain dark inclusions. The blending mode and opacity adjustment give their results. It remains to adjust the roughness and again tinker with a more fine-tuning. It's just time to add scene elements. For the plane, we will again create a wood material, but this time I will use a different texture, fractal noise. Fiddling with the settings and quite a decent result is now the most difficult and responsible. Installing and configuring the camera and lighting sources. Since the scene is very small in size, it is necessary to lower the aperture value. I will adjust it later. For convenient positioning of the camera, you can enable the view mode from the camera. It is important not to forget to turn it off later. To rotate and move several objects, it is convenient to place them in a common parent object. To do this, I use an empty object. I plan to make the scene dark and also use camera focus blur so the background will be poorly visible, and it can be made from the same plane on which the main object is located. It's time to do the lighting. In the world settings, I set the intensity of the environment texture to 0. The first light source, the main one, will be located on the top right. You can add a limiter to the light source and specify the object to which the light will always be directed as the target. The second light source is located on the left to highlight dark areas, and a third one at the back to highlight the outline of the object. The third light source creates a very bright spot on the plane of the table, so I will exclude its influence on the table. To do this, in the settings of this light source, I will set the ED light pass equal to 2, and in the properties of the plane object, I will disable this pass in the light pass mask parameter. I use an empty object as the focus object. Adjusting the aperture value so that the main object is in focus and the background is blurred, I edit a bottle. I will tell you about how to model a bottle, as well as create a label for it, in one of the following videos. In the environment settings, I will add a little power to the environment. A few more details before the final rendering. I add a vignette, slightly increase the saturation, activate noise reduction, add chromatic operations, set the maximum number of simples, the size of the final image in pixels. Setting up rendering layers. In the Octane render editor, I create a new node tree. I will open the Blender compositing window and the image editor window in order to see the rendering result. Press the coveted F12 and the render begins. Upon its completion, it is possible to save the image with and without noise reduction. To make small adjustments, I will use the online editor again. In the next video, I will talk about the process of creating a bottle of whiskey. In the meantime, I remind you about our unique group of like-minded people and fans of the Octane render in a Blender. You can download the file of this project for free there. So join in and be tireless.